Okay, in this video, what I want to do is address more advanced topics regarding Lewis formulas, drawing structural formulas of molecules. There's a total of 6 videos in this playlist. The first 5 videos lay the foundation for how you draw a Lewis formula, how you convert a chemical formula into one that shows the connectivity between the atoms. And in the 5th video, I dealt with more advanced matters, the structure of ethane, ethene or ethylene, and ethine. And what I want to do in this one is address some of the beginning concepts in drawing structures in organic chemistry. All right, so what I want to do is start by looking at ethane again, and if we draw the Lewis formula for this, and since we did it in the last video, I'm just going to go straight to the structure. All right, and what I'm going to do is leave one of the hydrogens off, but I'm going to put the bond in. So this molecule, the way the chemical formula is represented right here, all right, is a complete molecule. When I draw it like this, where most of the molecule is here, but we've dropped off one hydrogen, we call this in organic chemistry a functional group. It's a functional group. So it has the majority of physical and chemical properties of ethane. And what we're going to do is combine this molecule with something else. All right. And what we're going to do is actually make a common alcohol with this. So what I want to also do is put water back up here. So we're going to have H2O. And this was the formula that we started this whole video series out with. And we can draw the water molecule this way. Only what I'm going to do is leave one of the hydrogens off. So this is what the water molecule would look like if we took one hydrogen away. And this has a name in organic chemistry too. This is called a hydroxyl group. A hydroxyl group. All right, which comes basically from water, where all we've done is remove one of the hydrogens. So now if we compare notes here, we compare these two functional groups together, we can produce a new kind of molecule by simply taking the hydroxyl group and attaching it to the ethyl group. So the new functional group here, when we pull a hydrogen off of this, instead of calling this ethane anymore, we're going to call it ethyl. All right, and so let me rewrite that here. It's going to look like this. And then what we're going to do is add the OH to it. And I'll use a red bond to indicate the connection. All right, and then we'll put on the OH. And what we've done by combining these two functional groups is we've produced a new molecule now that has the combined physical and chemical properties of the two individual molecules. All right, so this is called ethyl alcohol, or ethanol. Now, if we go into the Lewis formula rules, you should, if you're still fuzzy on this, redraw this molecule using the rules, and you'll find out when you sum total everything together here, and then if you go through the steps the way I've described them, you will in fact arrive at this molecule the way I've drawn it. Now, what I want to do here is illustrate the basic application, how we combine different different structural formulas together to get different kinds of molecules. All right. The next one that I want to address is where we take the same idea now. So we're going to take the ethyl functional group, which looks just like ethane except we've pulled everything off of it, and we're going to combine it with a derivative that comes from ammonia. So let's take a look at ammonia. All right, its chemical formula is NH3, like this. So let's quickly apply the steps to drawing this formula, and then I'll show you how we're going to combine the ammonia molecule with the ethyl group here to produce something that's new and different. All right, so the first thing that we're going to do is calculate our total valence. So the nitrogen is in group 5. There's 5 valence electrons, and then we've got 3 hydrogens. The hydrogen's out of group 1, so we have 3 times 1. And you see the grand total. Our magic number in this case is going to be 8 electrons. So then we draw the skeletal structure, and I'll put the hydrogens around it. Okay, getting ahead of myself there. Just take that out for a second. All right, so now we have our skeletal structure. And the next thing that we're going to do is go ahead and connect the atoms. All right, now we do a quick count. 2, 4, 6 electrons we've used out of the 8. We've got 2 to go. And as described in the steps, we start with the middle atom and we add our pair of electrons here. Now we count to see how many electrons we've used. 2, 4, 6, 8. So we've hit the magic number. The number that we've used matches the number that we set out with. And when we look back at the molecule, we can see that there are in fact 8 electrons around the nitrogen. All right. So now imagine a scenario where we take and we remove one of the hydrogens. So now what we have is something that looks like this. It's a derivative of ammonia. But what we're going to do now is take this part of the ammonia molecule and we're going to combine it with the ethyl group. And the new molecule is going to look like this. All right, and in organic chemistry, this kind of molecule this actually represents a class of molecules, a group of molecules that are called the amines. All right, and technically speaking, this one is called ethyl amine. Okay, ethyl amine. And the new molecule has physical and chemical properties that are a combination of what ethane normally operates like and what ammonia normally operates like. So the purpose of this video is just to sort of open the door to extending, or the application of your ability to draw formulas and to be able to begin to apply that to organic chemical applications. And I think we actually have time for one more. So I'm going to change this up a little. We're going to say that we're working with methane. So that's CH4, and we're going to combine that with a form of HCN. All right. This is a weak acid, and then methane is a gas at room temperature. This is actually the main component of natural gas, or LP gas, natural gas. All right, now, so what we're going to do is, and it's called methane, so we're going to make a functional group out of this, and the way we're going to do that is by taking one hydrogen off. So I'm going to rewrite the molecule this way. And we would call this a methyl group. All right, and then we're going to do the same thing here, but we need to quickly expand the structure of this. So let's go ahead and apply the steps to this quickly. So we have, for carbon, we have 4 valence electrons. For the nitrogen, we have 5 valence electrons. That's a total of 9. And then we have a hydrogen for a grand total of 10 electrons. If we write the skeleton structure, we're going to do it like this. And if we just go through and we apply steps, all right, then I'm going to bond this, and I'm going to bond this, and then I'm going to come in with my unshared pairs and place them around all the atoms so that we end up with 8. And then I'm going to do counting. So we've got 2, 4, 6, 8, 10, 12, 14 electrons. So this structure is not possible. Now I did this deliberately because I want you to remember that in a previous video that we actually did the structure for Cn-. And hopefully you're remembering that, hey, ChemDoctor, there's more than a single bond between the carbon and the nitrogen. So let's just cut to the chase. The actual formula of this is going to look like this. And it has a triple bond in there. You can confirm this yourself running through the steps and doing the test. So now if we count, we've got 2, 4, 6, 8, 10 electrons. All right, so we've met the magic number. All right, so the magic number is met. And then you look at the individual atoms here, and there are 8 electrons around the nitrogen and 8 around the carbon, and we should only have 2 next to the hydrogen. Now, the purpose of this is to combine these 2 functional groups together into a new molecule. All right, so what I'm going to do is rewrite the methyl group this way. All right, and I'll make the connection bond in red. And then we're going to have a C here. And then we're going to have that triple bonded to our N with 1 pair of unshared electrons here. All right, so now you can see by combining these 2 molecules together, we've created a new function. We've created a new molecule, which is a combination of the 2 functional groups from the 2 previous molecules. So this is going to have this is going to have new physical and chemical properties that are a combination of the properties that were delivered by each unique molecule to start with. And this molecule, this is actually an organic, this is called a nitrile group. Nitrile, and the name of this compound is called acetonitrile. All right, and that pretty much brings to close this particular video as sort of an introduction to the idea of functional groups and how to combine them in organic chemistry.